Okay, so we're almost done with part A of this example. We just need to know when is it increasing and decreasing. So again, we can imagine what's going on here with this parabola. It's opening up. So from left to right, since it's opening up, from left to right, it's going to start off decreasing. And then once it hits that vertex, it's going to start increasing again. So it's actually decreasing from negative infinity up to the vertex, so up to -5. And then from there, it's going to start increasing again. So increasing from -5 up to infinity. So then we can use all this to help us graph once again. So part B is we're going to graph that same function that we just wrote down all the information about. So this time it said that there was a vertex at -5, -2. Okay, so when I draw my axes in, this time, let's see, I'll just draw the y-axis here, and I'll put my x-axis about here. Okay, x, y, and I'm just going to go by ones. Alright, so first thing we can plot is the vertex. The vertex was -5, 3, 4, 5, -2. This is where it said the vertex was. When we plugged in, when we found -b over 2a, that was -5, and we plugged it in to get -2. And then we can use the whole, it's opening up, and a is 1, so there should be a point right 1 and then up this number. So right 1, up 1, and then left 1 and up 1. Give us some more points. And then you're welcome to plot even more points if you want. Plug in different numbers for x and see what y is going to be, and you can plot those. But this is fine for us. And this could also be called f of x there. And that's our graph. Okay, and let's do one more of this form. G of x equals -x² over 2 plus 4x plus 8. So let's write down A and B and C. B and C are easier. What's B? 4, C is 8. And then for A, remember it's always the number that's in front of the x squared, so really you could think of this as being -1 over 2. So in this case, A is less than 0. Okay, so now we're prepared to actually find the rest of this information. The vertex, since it's in this standard form, we need to find -b over 2a. So -b would be -4 over 2 times a, but in this case a is -1/2. Well, in this denominator then the 2's cancel and I'm left with -1. -4 over -1 is +4. And then what we do, that would be our x value for the vertex. So to find the y value, we'll just plug that in to the function, f of 4. So we get -4 squared over 2 plus 4 times 4 plus 8. So we have -16 over 2, which is -8, plus 16. Well, actually, this -8 and this +8 will cancel, and we'll be left with a 16. Okay, so let's see. Alright, so this is telling us that the vertex is 4, 16. Okay, and then the axis of symmetry is going to be x equals, it goes through the vertex 4. And then, is it opening up or down? Well, A is negative, so it opens down, and thus it has a maximum. So the maximum that it's going to reach is at that vertex, so the highest it's going to reach is 16. And that happens when x equals 4, and no minimum. Okay, so let's graph this. Oh, just kidding. We're going to find the range and increasing and decreasing. Okay, so the range is bottom to top, but it's opening down, and it's opening down, that's the vertex, so it's opening down, and then the highest point is 416, so it's going to go from negative infinity up to 16. So the range is negative infinity up to 16. And then it's going to be increasing, it's opening down, so it's going to be increasing until that vertex, from left to right. So negative infinity up to 4. And then once it hits that vertex at 4, it's going to start decreasing. So 4 to infinity. And then if you just want to double check, we can graph it. So the graph, let's see, the vertex is at 416, so maybe I need to change my scale this time. So let's see. Put that line there. Okay, so let's see, and I'll call that f of x. So this time maybe I need to reach 16. 2, 4, 6, 8, 12. So let's go by 2's on the vertical axis. (10, 12, 14, 16). Okay, so actually if I go by 2's, 16 is going to be that very top one. And then we can still go by 1's on the x-axis. So the vertex is 416. So I have plot that point right there. And then it's opening down, so I can go a is negative 1/2, and in this case we find the absolute value of a, and so there should be a point right 1 and down 1/2. But remember that since I went by 2's, if I go right 1, that's here, but down 1/2, if I go down to the middle, that's going down 1, so I need to go half of that, which would be there. If I go left 1 and down 1/2, it'd be about there. And then we can plot everything. Or another thing I could do here is if I plug in 0, that one will come out nicely. If I plug in 0, get 0, 0, and 8. So also, in this case, I'm going to put a point there. That helps me get a better idea of where my graph is. So it never hurts to plot more points. And if I do that, then I know it's symmetric. So actually I know there should be a point. Let's see, so that's the vertex. That's the axis of symmetry. Go 1, 2, 3, 4. So here it'd go 1, 2, 3, 4. So there should also be a point there. And so we could plot it in and see if that happens. I get negative 34 plus 32. So negative 2, 8. If I plug in 8, get 8 squared, which is 64, over 2, which is negative 32, plus 32. Yep, I get that. So something like that. Okay. Okay, and then we will do one last example. So a model rocket is launched with an initial velocity of 100 feet per second from a hill that is 20 feet high. The height in feet after it is launched is given by the function s of t equals negative 16t squared plus 100t plus 20, where t is time in seconds. When will the rocket reach its maximum height? Okay, so if you think about this, this is a parabola because it's in the standard form. And it's opening down because a is less than 0. So we are going to have a max height. And the max height is going to be at the vertex. So we'll find that vertex. In this case, we need to find minus b over 2a. So let's write down what a and b and c are. A is negative 16, B is 100, and C is 20. Okay, so let's finish up this example, and then I'm going to talk a little bit more about one other thing. So we're trying to find the vertex minus b over 2a. So that should be minus 100 over 2 times negative 16. So we get negative 100 over negative 32, and that turns out to be 3.125. And then since we're finding the vertex, we would plug that in to find the y value of the vertex into the, actually we're doing s. The function is called s, so s of 3.125. So we have negative 16, 3.125 squared, plus 100 times 3.125 plus that 20. And I'll just tell you that this turns out to be 176.25. So our point that it reaches the vertex is 3.125 comma 176.25. So that's our vertex, and in this case it's really representing t comma s of t. Instead of x, y, we have different variables, t and s of t. So this is our time. T represents time, and s of t represents the height. That's what the problem told us. The height is given by that function. So the question was asking when will it reach its max height. So it's asking for time. So the rocket will reach its maximum height 3.125 seconds after it's launched. And then they could also ask you height. The max height would be the 176.25, and it says it was in feet. So that would be the y coordinate, or the s of t. Okay, and then one thing I wanted to go back over in this note outline, I'm going to go back through all the graphs, because there's probably some extra information that you should be aware of as well. So I'm going back to page 2. So I always plotted the vertex, and then I went right one, up whatever, left one, up whatever. But it's a good idea to put that in a t-chart. So here the vertex was 2, 1. So I'm going to put that in the middle. And then to go right one and left one, that's really adding one and subtracting one to the x value. So 3, add 1, and subtract 1. And then what we did for the y values is we went up 3 each time. So we took this original y value, 1 plus 3, and that equals 4. So here 1 plus 3 equals 4. So here we have these points. We have 2, 1 already, that's the vertex. And then these would be the other 2 points. We have 1, right 1, up 4, right there that we already plotted, and then right 3, up 4, which we already plotted. So this is just a way to actually find out what those points are. Okay. So let's do it for the next one on page 3. So for this one, what was the vertex? The vertex was at -1, 1. I'll put that in the middle. And I'll do the same thing. You take this x value, subtract 1, and add 1. So we'd get -2 and 0. -1 minus 1 is -2. -1 plus 1 is 0. Then for the y, we need to take this y value, which is 1, and add the absolute value of a. Let's see. Oh no, we have to subtract because we're going down, sorry. 1 minus the absolute value of a. So we'd go 1 minus 2, which is -1. And then we'd do the same thing here. 1 minus the absolute value of a, so 1 minus 2, which is -1. So here's our vertex, which we plotted -1, 1. And then the other points are -2, -1. So -2, -1, which is there. We already plotted it. And then 0, -1, which we already plotted as well. Okay. Okay, let's do that here on page 5. First, put the vertex in the middle. So this time, where was the vertex? 1, 2, 3, 4. Here's -5, -2. So our vertex was -5, -2. So I'm going to subtract 1, so I get -6, and add 1, I'd get -4. And this time it's opening up, so I take this number here, -2, and add 1 to it, which is a. Add a. -2 plus 1, -2 plus 1, so this is -1, -1. So we plot our vertex, -5, -2. We also have the point -6, -1, which is there, and we also have the point -4, -1, which is there. All right, and then I think we have one more on page 6. So we already plotted some, but let's just do this technique. So the vertex turned out to be 4, 16. All right, now from this 4, subtract 1 and add 1, so 3 and 5. And then we take this 16. This time it's opening down, so we do minus the absolute value of a minus the absolute value of a. So we do 16 minus a half and 16 minus a half. Okay, so that basically brings us to 15 and a half. If we take 16 and subtract a half, we get, and I'll just write it as 15.5, and same with this one. And we already have those plotted. We have 4, 16 plotted, and then we have 3, right 3, and up 15 and a half, and we have right 5, up 15 and a half. So this is when you need to know exactly what the coordinates are of some more points, of these points. Okay. All right, so now that will wrap up our notes for section 3.2.